David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. Today's topic, evaluating limits by dividing out. Now this is a nice little technique that's going to help us evaluate limits that's a little quicker than running it all into a table in like an application like Desmos or under Graphing Calculator. So let's get started. Okay, let's evaluate this function here with this limit. As x approaches -1, how can we approach this one? Well, simple, there's no division by 0 here, so we can just plug our -1 in for x and evaluate our limit. So this is going to be -1 squared minus 1 minus 6 over -1 plus 3. So this is going to be, this becomes 1 minus 1, keeps that at -6, and this is over 2. So our limit here is -3. That's pretty simple, just direct substitution. So that's cool. Now let's bring back our divide by 0 problem. How about same function, but now let's take a look at as x approaches -3. Okay, so we can't plug -3 in on the bottom of this fraction because we can divide by 0. So check this out. Dividing out allows you to cancel these annoying terms that with our limit that we can't evaluate directly. So let's take a look. If you noticed that the top of this expression is factorable, that's a good eye. So let's do that. This is going to be x plus 3 times x minus 2 all over x plus 3. Now, if you need to review your factoring, you should probably do that. I do have other videos that talk about factoring quadratics, so just let me know and we can get you going on that. So, now that I've factored the top, guess what? I've got some canceling I can do. There. So that x plus 3 term that is troublesome with our limit is no longer there. So now we just have our function is x minus 2, and then I can do direct substitution with that. Let's plug the -3. -3 minus 2 is -5. Okay, here's one for you to try. New function, limit as x approaches 2 of this function. So go ahead and pause the video, see if you can factor the top and do your dividing out and find the limit. Okay, let's see how you did. The top, as you recall, what we're looking for is 2 factors that multiply to -14 but add up to +5. And those would be x plus 7 times x minus 2 all over x minus 2. And here's a little clue in these problems. One of the factors should be this number because you need an x minus 2 on the top. So that helps you narrow down your factors. So check this out. Now I can factor out my x minus 2. This is x plus 7. I can plug in my 2 and the limit of this one, let's write L. The limit equals 9. Okay? Okay, here's one for you to try. X minus 1 over x cubed minus x squared plus x minus 1. And you're going to notice that our limit is as x approaches 1. If I plug 1 in for x here, the bottom goes to 0. I can't do direct substitution. So what I'm going to need to do is factor my bottom and find an x minus 1 term in here so I can do some canceling, and then I can take a look and see if I can evaluate by direct substitution. So pause the video, give this one a try. Okay, let's see how you did. This is a little bit more tricky. This is not a quadratic function, so you can't just factor in the normal quadratic way. But let me show you how I would do this one. Top stays x minus 1. On the bottom, I can get an x squared out of that. So I can go x squared times x minus 1. So there's an x minus 1 term. So I'm doing good. Now, this one doesn't look like you can factor anything. But always remember, you can factor a 1 out of anything. So I'm going to get plus 1 times x minus 1. So check it out. Now I've got a pretty nice problem. I've got an x and a plus x squared and a plus 1. So this is going to end up being x squared plus 1 times x minus 1 over x minus, or under x minus 1. Here I can cancel. And so now let's rewrite our limit. This is the limit as x goes to 1 of 1 over x squared. Let's fix that. X squared plus 1. Now this one I can plug 1 in all day, so I'm going to plug 1 in for x squared. That's still 1, so this ends up being 1/2. That's our limit. Evaluating limits by rationalizing. So let's take a look at this technique. Here's a limit. I've got as x approaches 0 of square root of x plus 1 minus 1. And I have x on the bottom. So I can't use direct substitution. I can't put in 0 for x because I have division by 0. Can't do that. So what we're going to do is we're going to do this technique called rationalizing the denominator. Now you may have bumped into this before for a process where we rationalize the numerator or the bottom of a fraction. In this case, we're going to do that to the top. So what we're doing is we're rationalizing the denominator, the top of the fraction. Now, what does rationalizing mean? It's pretty simple. It means get rid of the root signs, okay? So we're going to use a technique that we know from past math that you've probably had, hopefully. I'm going to review it right here, so in case you don't, you'll get it. Okay, so what we're going to do, I'm going to pull this function out and we're going to do this process to it. So here's our function, x plus 1 minus 1 over x. Now what we're going to do is we're going to multiply this thing by 1. So we're not going to change it. You have to remember, you can't change anything. You can only multiply by 1. So check this out. I'm going to multiply it by x plus 1 plus 1 over x plus 1 plus 1. Just like that. Okay, so let's take a look at how this works. But first I want to review this expansion pattern just so you can see really clearly how this works. The expansion pattern is this. If I have a plus b times a minus b, this is an old FOIL problem. You multiply the first, that's a squared, the outside minus ab, the inside plus ab, and then the last, which would be minus b squared. And if you look at this pattern, you're going to see that these two middle terms cancel out, and our result is just a squared minus b squared. So this is the difference of squares expansion pattern. You can run it backwards and do factoring as well. So we're going to use that on this function. Here's my a, and here's my b. A and b. So I have a minus b times a plus b. So now I can use that pattern to expand the top of my function. And what's going to happen is the root signs are going to go away. So using the pattern, the first term is a squared. So the square root of x plus 1 squared is just x plus 1. So that's our first term. Our b squared, our minus b squared, is just going to be this term squared, which is again just 1. So that becomes minus 1. Now in this one, I'm just going to bring it over and do x times root x plus 1 plus 1. You're going to see why I do that in just a sec. Okay, so let's simplify the top. X plus 1 minus 1 is just x. And this is still x times x plus 1 plus 1. Now I can cancel. And this is going to help us a lot. So this ends up giving us the function of 1 over root x plus 1 plus 1. Now let's come all the way back. So what I just did here is a bunch of algebra on our function, and hopefully that gets in a place where we can now evaluate this limit by direct substitution. So let's see how that looks. I'm going to rewrite my limit. Limit as x approaches 0 of our equivalent function, 1 over root x plus 1 plus 1. Now this is the same function as this one. We just rationalized the denominator. And now, whoops, I left my 0 out. Here we go. Now we can plug 0 into this function with no problem. 0 for x means this is just root 1 plus 1, all under 1. And we know the bottom is going to now be 2, 1/2. So our limit, as x approaches 0, of 1 over x plus 1 under the root sign plus 1 is just simply 1/2. Okay, let's look at certain operations with limits. There's no real algebraic trick here or new process. It's just about how you can combine limits or how you can do operations on limits. So we have 5 different patterns here. They all pretty much make sense. You might be able to intuitively figure them out even if you didn't have this video to show you what to do. So let's take a peek. So first, to set the stage, the limit of f of x is L. Whatever function that is, we're just going to say the limit is L. As x approaches some number, we have a limit for f of x. And then the same thing for g of x. We have some function, again, g of x, we're testing the limit as x approaches some number, and that limit is k. Okay, so we have these two established functions. They have defined limits, they exist. Now let's take a look at doing some operations on those limits. So the first one, multiples of the limit. So what that is that's the limit times some number. Okay, so now if we take the limit of some number a times f of x, then the resulting limit of this is just going to be a times the limit of f of x. Remember, L is the limit of f of x. So it's pretty simple. If you just see some number times your function in there, then you're just going to multiply that number times the limit of the function to get the new limit. Sum and difference, real similar. Here we have the limit of one function either plus or minus another function, f plus or minus g of x, and that's just going to be the limit plus the other limit, or the limit minus the other limit. So you would figure out these two limits as x approaches some number, and then you'd either add those two limits together or subtract them. Pretty straightforward. Product, again, real similar. If you have a limit of one function times another, then you can find the limit of each function individually and then just multiply those limits times each other. And that would be the limit, the new limit. Quotient is just the reverse of product. If you have a limit, if you take the limit of one function divided by another function, you just need to find the limit of the top function, the limit of the bottom function, and then divide those two limits together. Lastly, the power rule is the limit of some function raised to a power. It's just going to be the limit of that function, L, raised to the power n. And that's pretty simple. Okay, let's do a couple quick examples, and I think you're going to see just how easy this process is. So I've substituted some actual limit numbers. So f of x, the limit is 5 as x approaches some number. We're not diving into the limit itself. We're dealing with the process of the limit. We're dealing with the actual number that is the limit. So f of x has a limit of 5. G of x has a limit of -2. Here are 3 problems. Take a look at the notes you just took. Pause the video and see if you can get these right. Okay, so this one's that first one. This is multiples, or multiplying. We just have 7 times the limit of f of x. So that's just 7 times 5. This one is 35. Okay, pretty simple. Now, f of x times g of x. If you haven't tried this yet, pause the video, give it a try. Okay, so all we do in this case is we just multiply the two limits. So this one's -10. Okay, last one, let's try the power rule. Here's the limit of f of x, but now we're squaring that, okay? So here's f of x, there's the limit, it's 5, squared is 25. Pretty straightforward. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.